Welcome everyone. Here is one exam question covering 12.1. In this case we're doing an exam from fall semester 2017. This is problem number 8. We're asked to find the radius and center for a sphere with this given equation. So we have some different centers and some different radiuses. You can see this is a multiple choice question, but it could certainly be asked as a standard response, right? And you just kind of forget about all this stuff here. So let's go ahead and review, right? What is the main kind of formula or equation or theorem that we need in order to solve this problem? And so it goes something like this, right? A standard form for a sphere looks something like there's an x minus some x value squared plus y minus some y value squared plus z minus some z value squared is equal to r squared. So this is a sphere with center, and this is x naught or x sub 0, y naught, z naught, right? So this is the center, and then it has radius r. So we need to get our equation to look like this. If I can get my equation to look like this, well then I'll know what the center and I'll know what the radius is. So let's go ahead. I see that all the stuff with x's, right? So we just have one x's, it's an x squared term right here. I can go ahead and rewrite this as x minus 0 quantity squared, right? So this is saying that my x sub 0 term, right, is just 0. Okay, likewise for the y's, I can make this y minus a negative 1 quantity squared, right? Because you notice that there's all these minus signs right here. So y minus y naught. So instead of plus 1, I'm writing it as minus a negative 1. So that's saying that my y sub 0, right, is negative 1. And in fact, if I want to go ahead and maybe start substituting some of these things in here, right, I have 0, and my y sub 0 here would be negative 1. And now the most difficult one, right, the z1. Right, this has a z squared and a z, right? In order to get this into a perfect square, right, I need to use this idea of completing the square. So in order to complete the square, right, we're kind of looking at the 6. And the rule goes that we should divide this by 2 and square it. And that's the good thing to add. So if I divide 6 by 2, I'm going to get 3. And if I square that, well, 3 squared is 9. So I'm going to go ahead and add 9. So plus 6z plus 9. And of course, if you add something to the left-hand side of the equation, you have to add it to the right-hand side. So that's going to be 16 when I add 9 to 7. And so the claim is, again, this is the good thing to add. This becomes a perfect square, that this is something squared. And what is it squared? Well, it's going to be z plus 3. And it's always this number divided by 2. So 6 divided by 2 is going to be 3. And of course, if you're at all paranoid, right, you double check, right? If I go ahead and FOIL this out, if I take z plus 3 and I square that aka I multiply it by itself, and I do the firsts, that would give me z squared. If I do the inners, that would give me 3z. If I do the outers, that's going to give me 3z. And if I do the lasts, that's going to give me 9. So if I simplify this down, do I get what I started with? Absolutely. So anytime you're paranoid that you've made a mistake, right, double check your work. So this right here is the same thing as z plus 3 quantity squared. And so if you like, right, we can go ahead and rewrite this all on this next line. Y minus a negative 1 quantity squared. Instead of z plus 3, let's go ahead and make this z minus a negative 3. Right? And 16 is the same thing as 4 squared. So now we can see that my z sub 0 term, or z naught term, is negative 3. And my radius is going to be 4. Right? Because it's r squared. So in this case, 16 is 4 squared. So my radius is 4. So my center is 0, negative 1, negative 3. And the radius is 4. So therefore, I like D the best. All right, that's it. That's one exam question that dealt with 12.1 that has been seen in the past. I hope you guys enjoyed. I'll see you hopefully in 12.2.